Hello, my name is Alan. I'm the CEO of Quintessent. Very happy to be here with Eric and meet him in person for the first time. Quintessent is working on solving the communication bottleneck between compute chips within data centers and AI training clusters. I started Quintessent in 2019 with my co-founder, Professor John Bowers, who was also my PhD advisor at UC Santa Barbara. I spent 2 years in Washington, D.C. as a consultant for Booz Allen Hamilton after I finished my PhD at UCSB before starting Quintessent. And very fortunate to have the support of Foothill Ventures along for the journey, and very excited to be here. Sure, so the core problem that we are solving is that the fundamental unit of computing now has shifted from being a single compute chip, be it a CPU or GPU, to a whole cluster or even a data center of compute chips, which is to say that solving the most prevalent workloads and problems of today, like generative AI, requires the orchestration of thousands, even tens of thousands of compute units in parallel. And the implication of that is at the system level, the bottleneck that limits the application performance, runtime, et cetera, it's no longer how fast an individual compute chip can crunch numbers by itself, but actually it's how fast they can communicate with each other. And that is a bottleneck that has existed, and it's actually getting worse. So compute chips obviously get faster and faster with each new generation, but the rate at which they communicate with each other is not keeping up. The implication of this is that we can't actually feed the compute chips fast enough with enough data to keep them fully utilized. That results in huge inefficiencies in terms of how well you're utilizing the very expensive compute hardware that data center operators and AI end users pay for, and it also limits the scale of a problem you can solve, and it also limits how fast you can solve a, for example, machine learning training problem. Absolutely. So fundamentally, we know that a solution requires optical interconnects, which is moving data with light. The reason is that it's fundamentally more efficient to transfer data using photons than electrons. And the challenge then becomes, if you just try to brute force scale today's technologies in order to meet the needs of AI training clusters and data centers, you pay a very expensive penalty in power, in cost, in area, and in latency. And those are just fundamental limitations of today's existing technology, and also part of that just is a result of fundamental physical scaling laws that we run up against. And so what we're working on at Quintessent is we are tackling the problem from the foundational layer. We think there's a paradigm change that is needed we think that there needs to be a new paradigm for communication in order to solve the communication bottleneck between compute chips. Doing so and implementing that practically requires a new set of foundational technologies to implement it in a practical manner, and that's what we're working on at Quintessent. So the technological innovations that underpin our solutions are threefold. One is we're leveraging fundamental advances in material science. We use a new material for our semiconductor lasers to make them more efficient, more reliable. The second is we use new novel designs for all of our photonic components that are needed for communication, and that enables us to squeeze much more performance and bandwidth and functionality out of an individual chip, which is to say we get, say, 8 to 10 times the performance for the price of one. And then finally, we combine all of our elements on a single silicon substrate, and that's manufactured in a silicon-based foundry. And so the net result is that we have a single chip solution that results in the simplest possible form factor, the lowest possible power consumption, and the highest possible performance for communications, leveraging the combination of those three different innovations, much of which resulted from early research that was done at UC Santa Barbara and Professor Bowers' lab. So if you look at the history of photonics, the primary application for photonics has always been to move data. And the trend has been that photonics is used to communicate across shorter and shorter distances. And with decreasing distances, the volumes of this photonic interconnect deployments increase. And so historically, the market was modest. but I would say it's always been growing and it's now ready to explode, especially with the huge pressures and interconnects that's being created by the proliferation of generative AI and all of the stress that places on the interconnect itself. If you look at past companies that were successful in serving those early photonic segments, there are many notable examples of multi-billion-dollar successes. So Infinera is one example, Finisar is another one, Lumentum is another one. And the commonality among those companies is that they were all vertically integrated in the sense that they owned their own manufacturing and they built up their own manufacturing capacity from the ground up. That's a very expensive proposition, and so obviously it's very capital intensive, and so it increases the barrier to entry for a successful photonics company. So I think those were the two main limitations for what you asked, which is before there was a healthy market, but it was modest, and then two, in order to be successful, you had to be vertically integrated. What's changed now is both of those things have now changed in the sense that, one, on the market side, there's now a huge demand for photonic interconnects, and there's a huge opportunity to integrate photonics closer with the compute element and have them be deployed in a much more pervasive scale. And the second, the ecosystem is now also much more mature in the sense that photonics now looks a lot more like the microelectronics industry. You can do a lot of the functions of photonics with silicon-based materials. There's now a healthy foundry ecosystem that you can use to outsource your manufacturing of the photonic substrates and chips so that you don't have to build it from the ground up. And so fabless companies like Quintessent, we can benefit from that infrastructure by sharing and amortizing the cost of manufacturing with other customers that use the same foundry. And in exchange, we benefit from the shared learnings at a foundry of much tighter process uniformity, much higher yields that otherwise would be a very expensive investment for a single company. And so I think with those two shifts, I think now is a great time to be in the field of photonics. There's a great market opportunity, and the ecosystem is here that enables a fabless company like Quintessent to thrive. One thing that I would change is when we started off, we were very much a technology company in the sense that we had great technology and great innovation from UC Santa Barbara that we wanted to commercialize, and there were many different directions that we could have taken the technology in the sense of it was applicable to a broad array of different markets, applications. We looked at LiDAR. Our first customer was in the field of optical computing. Of course, we looked at communications. And at the same time, we were also successful in getting government grants and contracts to fund the development of that technology. But each of them were a little different and maybe tailored for a slightly different application. And so what ended up happening was we ended up getting pulled in a few different directions. And I think ultimately that diluted our company's strategic focus. And so one thing that I would definitely do differently is from the very get-go, prioritize on finding strategic clarity and direction in terms of what the ultimate application and product that we want to focus on is. We absolutely ultimately did end up getting to that point of clarity, which is we want to apply our technology to solve data communication. But I think I would have just focused on getting to that point of clarity much, much sooner so that we can then have the entire organization be aligned and pointing in the same direction, rather than getting pulled in a few different directions and maybe not moving as fast in any one of them.